The use of utility AI can be found in many applications today, from autonomous vehicles to healthcare management. Utility theory is not a new concept and was there long before computers. Uses include game theory, economics, and many other fields. Let's explore how utility AI is used within games by taking a closer look at The Sims. The Sims is a life simulation game series developed by Maxis and published by Electronic Arts. First released in 2000, the series allows players to create and control virtual people called Sims and simulate their daily lives. The original, released in 2000, introduced the concept of life simulation and basic gameplay. In 2004, Sims 2 was released, which added 3D graphics, life aspirations, and more complex relationships. The release of Sims 3 in 2009 introduced an open-world environment. The latest version at the time of this video, released in 2014, Sims 4 focused on emotion-based gameplay. While Sims 4 became free to play, many expansion packs are available for purchase to enhance gameplay. Decision making is at the core of any AI system. There are many different approaches to decision making. One of those approaches is a utility-based system. By itself, it is a very simple and straightforward approach. In The Sims, these values are used to drive the behavior of a sim. The player can queue stuff to do, but these values will always be used otherwise. There is also emotional values which drives how the sim feels, which can affect behavior. Based on utility functions, which are mathematical representations of goals, utility AI aim to maximize an expected outcome or utility by evaluating different possible actions and their potential results. Utility is not the same as value. Value is a measurable quantity, but utility measures how much we desire something. Therefore, normalized scores, values between 0 and 1, provide a reasonable starting point. Normalized scores combine very easily through averaging and are very easy to compare since they are on the same scale. The key to decision making using utility AI is to calculate a utility score for every action the AI agent can take and then choose the action with the best score. Provided a reasonable scoring system, utility AI is very good at making a best guess based on incomplete information. The key to utility theory is to understand the relationship between the input and the output. This can be thought of as a conversion process, where you convert one or more values to utility. Consider a problem faced by all Sims, namely hunger. All Sims have a hunger value which measures how full they are. One solution to manage hunger is a custom curve. The idea is that you hand-tune a group of 2D points that represent the threshold you want. Here is an example of NPCs going about their business. Every time an NPC moves, it is a reduction in energy. If the energy level goes below a set threshold, the NPC needs to eat in order to replenish energy before continuing their day. This is the graph that is used to manage the relationship between energy level and hunger. All NPCs don't have to use the same graph either. A energy profile like this one can be set up setting the energy cost for each move, the hunger threshold, and the graph used to manage the relationship between energy and hunger. Each NPC can also have their favorite food, and each food type can replenish only a certain amount of energy, which may cause the NPC to require food more often. The implementation of utility can be as simple or complex as the game requires. This example uses Cope, discussed in this video with utility AI. Actions are implemented using a simple state tree first discussed in this video. The NPC has two goals, namely wander, representing going about their daily life, and find food, for when they're hungry. To accommodate the changing goals, the following was added. The goal was given an array of actions to fulfill the goal. The planner will now check the goal for actions before using the default set of actions. Create a data asset named energy profile. Add a float property named energy cost. Add a float property named hunger threshold. Add an object pointer of type curve float property named curve. Create a blueprint enum named emules. Create a blueprint structure named mule energy. Add a emules property named mule. Add a float property named energy. Create a data table of type mule energy. This table can now be used to specify how much energy is restored after consuming a selected meal. In the NPC blueprint, add a emules property named mule bias and a energy profile property named energy profile. Make both visible for changes in the world editor. Add a billboard component. Compile and save. Update the blueprint interface that will be shared by both the NPC and controller blueprints. Add a function named getMoveToLocation. Add a function named updateMoveToLocation. Add a function named getCurrentDestination. Add a function named updateCurrentDestination. Add a function named executeFinish. Add a function named getNextMeal. Add a function named restoreEnergy. Add a function getMealBias. Add a function named getEnergyProfile. Add a function named updateCurrentMeal. Add a function named clearCurrentMeal. Back in the NPC blueprint, implement the interface. Implement the function clearCurrentMeal. Implement the function updateCurrentMeal. Implement the function getEnergyProfile. Implement the function getMealBias. Compile and save. In the NPC controller blueprint, implement the interface. Implement function clearCurrentMeal. Implement function restoreEnergy. Implement function executeFinish. Update the function updatePlanner. The planner will now, based on the hunger threshold, select the active goal. New float variables hunger and hunger threshold are being used. Create a new function named updateEnergy. This function will update the current energy level based on the energy used. New float variables energy and energy cost are being used. Create a function named updateHunger. New float curve variable hunger curve is being used. Create a function named increaseEnergy. Create a function named setEnergyCost. This function will get the energy cost from the current energy profile set on the NPC. Create a function named setHungerThreshold. This function will get the hunger threshold from the current energy profile set on the NPC. Create a function named setHungerCurve. This function will get the curve from the current energy profile set on the NPC. Now update the begin play event to call these functions and then compile and save. Create a state tree. Create an evaluator named default. Add the evaluator to the state tree. Create a task named moveToLocation. Create a task named title. Set up the states in the state tree. Back in the NPC controller, add a state tree component and set the state tree. Update the begin play event to start the state tree. Compile and save. Create goal action find destination. Create goal action move to location. Create a wander goal. Create goal action get a burger. The precondition check is assigned an action task which will check if the next meal is a burger. If not, then the get a burger task is not included in the final plan. Create goal action get fish. Create goal action get pizza. Create goal action eat food. Create a get food goal. Create float curves to be used with different energy profiles. Create energy profiles. Create a blueprint actor named Waypoint. Add an arrow and sphere collision components. Add a gameplay tag variable and make it visible. Define destination action task uses the gameplay tag to find the waypoint where the NPC needs to go. Add waypoints to the level, including where the NPC will find the meals. Assign the NPC an energy profile and meal bias. Whenever the NPC moves, some energy is being used. which increase the desire to eat. When the hunger threshold is reached, the NPC will execute the find food goal and go to the fast food outlet serving their favorite meal. Now get the NPC moving and then check out this video to learn even more about AI in Unreal Engine.